Hi all, this lecture will be on the z-test for a proportion, which is the last lecture on one sample hypothesis testing. Like we saw before with the confidence intervals for proportion, the lowercase p is the population proportion and p hat is the sample proportion. And remember, p hat is the point estimate of p. So if we had to pick one number as the best guess for the population proportion, it would be the sample proportion. And just make sure you don't get confused with the p-value, which is the number that gets compared to alpha or significance level, and it's used to determine the conclusion of hypothesis test. So p in proportions is not the p-value. So just like the previous two tests, the t and the z, for the mean, we have three possible sets of hypotheses. These are in terms of p, the proportion, instead of mu, the mean. So since we are dealing with the population proportion, we have p in this case. So the null hypothesis is always p equals some hypothesized value, and the alternative hypothesis is p less than some hypothesis value, or p greater than some hypothesis value, or not equal to, depending on the problem. So just like we had before, less than is lower tailed test and greater than is the upper tailed test, and both the less than and greater than are one-tailed test, whereas not equal to is the two-tailed test. And here's the test statistic, which is the sample proportion. This is the sample proportion minus the hypothesis value divided by the square root of the hypothesis value all times 1 minus the hypothesis value divided by the sample size. It's not bad once you plug in, but you actually won't be doing this by hand, so it doesn't matter. But I think it will be helpful to see what the z statistic actually is. So, oh, and also we do the same as before. We reject h naught if the p-value is less than alpha, which is given. So here's an example. We have a sample of 300 women and find that 228 of them have ever dyed their hair. And using a 0.05 significance level, we want to test to determine whether more than 75% of all women have ever dyed their hair. And just a note, like the confidence interval, one way you know it's a proportion test is because you have x out of n. So in this case, it's 228 out of 300 women. So the alternative hypothesis is p is greater than 0.75. And then the null hypothesis is p is equal to 0.75. And it's 0.75 and not 75 because since we're dealing with proportion, it's always between 0 and 1. So convert the percentages to proportion. The sample proportion is p hat equals 228 over 300. So that equals 0.76. And if you plug in the formula, all the given values, so we plug in the sample proportion and then our hypothesis value, which is 0.75, and our sample size down here is 300. The test statistic is 0.4. So the p-values are calculated the same way as the z-test for the mean, and if we want to find the probability that z is greater than 0.4, that will be 0.3446. So the rejection rule is reject h naught if p-value is less than 0.05. Therefore, since 0.3446 is greater than 0.05, we fail to reject h naught, and there is not sufficient evidence to say that more than 75% of all women have ever dyed their hair. So keep in mind, we know that the sample proportion is 0.76. That's 228 out of 300. But we want to know, does that give us enough evidence that more than 75% of all women dye their hair. So according to this example, 76% in the sample does not give us enough evidence. And I won't make you do this by hand. We will use StatCrunch, but knowing how to do it by hand, like that example, is always helpful. So the next example, we'll just use StatCrunch. So suppose we took a sample of 200 middle school students. 88 were able to spell the word occurrence correctly using an alpha level of 0.05. Test to determine whether fewer than half of all students correctly spelled the word occurrence. So again, we have x out of n, so that tells us that this is a proportion test. So the proportion is 88 out of 200. They want to test whether fewer than half of the students spelled the word correctly. So that means our alternative hypothesis is P is less than 0.5 right here. So, and then our null hypothesis is always P is equal to 0.5. And then from StatCrunch, we calculated that the test statistic is negative 1.697, and the p-value is 0.0448. So with using an alpha level of 0.05 to compare, we reject H0 if p-value is less than 0.05. So our p-value in this case is less than 0.05. So we reject H0. There is sufficient evidence to conclude that fewer than half of the students correctly spelled the word occurrence. And the last thing, I just want to say that these problems should be fairly simple once you guys understand the basics of hypothesis testing. And this week, all we did was hypothesis testing. So they should be coming together like, if you know how to do the basic Z test for the mean, you'll know how to do the t-test and then the proportion test. So please let me know if you have any questions, and if you know how to know the basics and how to use StatCrunch, you should be okay. And I provided you example videos for you to understand StatCrunch, so ask me questions.